So let's look at an example of how we can use vectors to solve a simple word problem. So if you have a sheet of paper in front of you and a calculator, I want you to write down this example here. You can pause the video now if you can. An airplane is traveling due south at 400 kilometers an hour. It encounters a wind of speed 25 kilometers an hour from the west. What is the resultant speed of the airplane? Now, when you see this phrase used, what is the resultant speed of the plane? Basically, what it's asking is, well, how fast is the plane actually going if we take into consideration the fact that there is this wind that's approaching from the west at a speed of 25 kilometers an hour? We're going to use vectors to represent this scenario. So the first thing we do is draw a vector to represent the airplane traveling due south at 400 kilometers an hour. I'm going to sketch that over on the left side here. So if it's flying due south, there's the vector. Now I'm going to give the vector a name, or a symbol, and P for plane with a little arrowhead on top. Again, the magnitude is 400 kilometers per hour, and the direction is due south. There's a wind coming from the west. If the wind is coming from the west, then it's headed east. I can draw that vector from the same spot where I started to draw the vector of the plane. So I'm going to draw it here, but because the speed of the wind is not obviously as fast, let's erase that, and then what I can do is show the vector but not draw it as long as the one with the plane. So a short vector tells me that the magnitude is much smaller than that of the other vector, which makes sense because it's only going 25 kilometers an hour. So let's give that a name. We'll give it W with a little arrowhead on top. The magnitude is 25 kilometers an hour, and the direction is east because it's coming from the west. So how do we figure out the resultant speed of the airplane? Well, think about it logically. If the wind is coming from the west, then we know that the plane is going to be pushed slightly towards the east. It's not going to be traveling due south anymore. The speed may also change, or the magnitude of that resultant vector isn't going to be 400 kilometers an hour. It may be a little bit more because, again, that speed is sort of pushing that plane to go faster. So how do we do this? I'm going to use a different color, and I'm going to show you how to draw these vectors slightly differently so that we can solve this mathematically. Here's the vector to represent the plane again, and I'm going to draw the vector representing the wind, but instead of drawing it up near the tail of the plane's vector, I'm going to draw it from the head of the plane's vector. This way we have two vectors that are joined head to tail. That's how you always want to draw your vectors. It'll make much more sense when you're drawing the resultant. Well, what is the resultant? Let's use a different color. I'll use this bright yellow. The resultant vector is the one that's drawn from the tail of the airplane all the way to the head of the wind. That's your resultant. I'm going to give that a name. We're going to call it R. I want to know the direction and the magnitude of that yellow vector. That's what the question's asking. Well, how do we do this? We're going to turn this into a simple trigonometry problem. Notice that this is a 90-degree angle. We're just going to look at the magnitudes right now. I know that the magnitude of the plane vector is 400, and I know that the magnitude of the wind is 25. Well, how can I solve for the magnitude of the resultant vector? And again, we represent magnitude by using vertical lines around the vector. That tells me I'm just looking at the number. I don't care about direction right now. We'll get back to direction. Since that's a 90-degree angle, we're going to use Pythagorean's theorem. So r squared is going to equal 400 squared plus 25 squared. And work your magic with Pythagorean's theorem. We end up with the magnitude squared equals about 160,625. we need to take the square root of both sides. That will eliminate the power of 2. And the magnitude of the resultant vector, or the magnitude of the plane, is about 400, we'll round to 1 decimal place, 0.8 kilometers per hour. Now ask yourself, does that make sense? Sure it does. If the speed of the plane is 400 kilometers an hour and it encounters a little bit of wind, it's going to push it slightly faster, right? Not by much, but there is a bit of an increase. So the magnitude of the vector represents the speed of the airplane once it encounters that wind. Now the question becomes, what direction is this plane actually heading in? It's not going due south, it's being pushed. So what you need to do is figure out this angle that I'm drawing there, theta. What is theta? Well, again, it's a right angle triangle. We can use what we learned in Unit 1, SOHCAHTOA. I'll write it out here. Now, you have an option because we have all 3 sides of the triangle. I'm going to use tan because the opposite side would be 25 and the adjacent side would be 400. So this is opposite, this is adjacent. I want theta. So tan of theta is equal to 25 over 400. You need to use the inverse button on your calculator. So use second function or shift, then press tan, then enter in this fraction, 25 over 400, and you should get an angle of about 3.6 degrees. So that's what theta is. Therefore, we can say that our vector, r, which is the speed of the airplane with a direction, is equal to 400.8 kilometers per hour with the direction, again, use your square brackets. We're going to use the quadrant bearing. How do we represent the direction of that yellow vector? Well, south 3.6 degrees east. There are other ways to represent this direction if you'd like. You could give it in terms of the difference between 90 and 3.6, but this is very simple and straightforward and gives us a perfect answer of how this plane is actually flying. Another way that we can state this answer, and I'll just go to a new slide, is stating the resultant speed of the plane is the magnitude of the vector r. It is 400 kilometers per hour. The direction is south 3.6 degrees towards the east. Again, always make sure that your answers intuitively make sense. The wind is coming from the west, so it does make sense that the plane is going to be pushed slightly towards the east.